Okay, question 20 is a style question, so you've got to be really careful with how you write it down. Prove that the difference between the squares of consecutive odd numbers is a multiple of 8. If it's a proof question, you usually work with n. And that's basically, you use that to represent a number and then you manipulate it from there. So, what I'm going to say is the first odd number I'm going to call n. To get to the consecutive odd number, the next odd number, I add 2. Because obviously if this was 3, then that would be 5. We want the squares of consecutive odd numbers, so I want n squared and n plus 2 squared. So this one's fine, but this one I need to expand. I'm going to do a quick good method. N squared plus 2n plus 2n plus 4 is n squared plus 4n plus 4. And then it says the difference between the squares of consecutive numbers. So I need to do one, take away the other. So I'm going to do n squared plus 4n plus 4, take away n squared. N squared take away n squared is nothing, so I'm left with 4n plus 4. Now if I factorise that, I can get 4 times n plus 1. Now this is a little bit sneaky because 4 is actually a multiple of 8 technically, because 8 times 0.5 is 4. So 4 is a multiple of 8. So the difference, which is 4n plus 1, is also a multiple of 8.
When you see charts like this, you know you're in data handling. And if you look at this kind of chart, you're used to seeing this for either a cumulative frequency graph or a histogram. So it's going to be one of those two. Now, they want us to use it to find an estimate of the percentage. And I know that percentages are easier to find from a cumulative frequency graph. So that's the graph that I'm going to draw. So the first thing I'm going to do is on the end of here is I'm going to calculate cumulative frequencies, which means running total. So the first one is 40, next one is 100, 40 adds 60, then 190, 100 add 90, then 250, and then 250 again because it hasn't changed. Nicely, if I look at my graph, I can kind of see that I'm on the right track because this scale will fit 250 up the side. 50, 100, 150, 200, 250. Along the bottom, I'm going to need to go up to 80. So I'm going to go 20, 40, 60, 80. And then it's just a case of plotting the graph. Now remember, for cumulative frequency, you put the end of the group. So the first coordinate is 10, 40. So 10 is here, and then 10, 20, 30, 40. Next one is 20 and 100. So 20 and 100 is an easy one to plot. And then 40 and 190, which will go there. 80 and 250, bit of a jump there. And we'll stop there because 80 and 0 will just take us back down here. So that's not a useful bit of information. I'm going to start from 0 and I'm going to try my best to curve the graph up. So it's not a straight line, it's a curve. Because I've drawn the graph, if I don't put my labels on, I'm going to lose marks. So I'm going to put cumulative frequency up the side. And I'm going to put length in centimetres at the bottom. Sounds really silly, but that's going to cost you a mark if you don't put them on. It says, use it to find an estimate of the percentage of fish returned to the river. And it says here that fish are returned to the river when they're less than 50 centimetres. Now 50 centimetres is here. So what I'm going to do is get out my ruler. A bit tricky because I've only got one hand, but we're going to get out a ruler, draw a line up to there. And then we're going to do the same. We're going to draw a line going round the other way. So it's going to go along here. Now that tells me that 210 of the fish are less than 50 centimetres. So 210 of the fish caught are being put back in. That's 210 out of the 250 fish that are caught. I need to know this is a percentage, so I'm going to simplify it. That's 21 out of 25. And if I want to make that into a percentage, I just need to times by 4 to get to 100. So that's 84 out of 100, which is 84%. The only reason it's an estimate is because of drawing the line on. If I'd drawn my curve slightly higher, then your percentage would have been slightly bigger. So you might have 85% or 83%. Might not be quite the same as mine.